Welcome everyone. We're going to be covering what we're discussing for techniques, tools, strategies, parts you guys need to be making for the four-wheel drive cars in your teams. I had or thought I had an instructor car model already set up for SolidWorks, but it looks like that was lost somewhere in the data transfer loss from GCU. So there's some missing files out there. I've added a number of different materials, so let me pull those up. A number of different specific drawings. So AA battery holder, this one's a pretty important one. A lot of all of you are going to have to account for this in your volume. You're gonna have to make each part in your team. So now you'll have dimensions for these attached to the announcements. Similarly, two-wheel drive wheel, these are roughly the same size as everything that we're using. You should expect them to look sort of something like this with black tires, so they're not going to be as nice or as fancy as these injection molds, but the tires are going to be the same model as this, unless they've started doing more 3D printing of tires, which I kind of doubt has taken place yet. We have kind of a simple three-spoke design similar to this, kind of. Maybe we have some more options. We were starting to experiment with 3D printing wheels at the last time I was involved in the project. This is what the actual motor, the dual drive motor, looks like that you guys are going to be using. I've given you some specific motor dimensions here. So this is a side view. You have positive and negative on either side of this. So you have a couple key parameters. So 2 millimeters in here is your shaft diameter. 6.1 millimeters is this front coupling. So this shroud over the front. So 6.1 millimeters outer diameter. 6.15 actually, and then a 1.7 depth. So these are important figures to know because of you need to have something that sort of the front of the motor butts up against in order to hold it in place, and then something that holds onto the back as well. So the back looks like this, and all models, all types, the difference is how far the shaft sticks out if it's a double-sided drive like this one or not. So neither of these account for the dimensions, but the numbers on this one were a lot more clear. So the overall dimension is going to be a little longer. So A is going to be longer for the double-sided drive. For it's 38 millimeters for the single-sided drive, but this is about 9 millimeters instead of this little 2.3. So another about 9 millimeters out the other side, 9.4 or so, will get you about the correct dimension here, and that'll give you a reasonable range for being able to fit parts. D shape, so 10.1 millimeter diameter with a 4 millimeter cutoff to the D shape. All of this stuff is stuff you guys know how to do. The actual height of the motor itself is not completely round, so it is 20 millimeter diameter, but it's not actually a diameter, that's actually the width. So these are arc segments. Getting the curvature of these right is a little tricky, so you need to kind of pay attention. This maybe does a little bit better job of representing it, but that's kind of your starting point. So 15 millimeter height. You'll have to do kind of some matching to see, okay, does that angle look correct? So when you go to draw it in SolidWorks, the trick to that is going to be something like this. Even if I minimize this just a little bit to give us our reference. Yeah, like that. Even if you're drawing that, you're not really going to be served well by doing, let's adjust our view plane so that it's square. You're not really going to be served well by doing a set of circles. You can kind of do a set of circles referencing maybe midpoint of the rectangle or something like that. So circles. Sometimes SolidWorks is there to help. There we go. It's got my reference. So I'm going to set it there. So we've got one circle, and then instead of doing another circle, what you're actually going to want to do is you're going to want to set the arc points. So smart dimension, set this height as your 15 millimeter. Set this width as your 19.8. 19.8. This diameter is going to be on the real motors, it's actually going to be closer to this 10.1. So maybe this is slightly more accurate. So 10.1 diameter, and then a flat cut at 4 millimeters down. So a flat cut here, let's see, yeah. 4 millimeters down. And this will let you do a cut to this. We also want to have a distance here. This is going to be right at, let's see, half. So it's going to be about 7.5. Back into the smart dimensions. We're actually making movement. So we're going to be right about 7.5 millimeter, so that it's at the center. Then we're going to come in and trim entities. So that we're left with the geometry of interest, something like that. And then to recreate those arcs, what you'll see is these arcs are related to these. So we know what the curvature is going to look like. It'll still be easiest to do like a 3-point arc, something of that nature. So starting a little bit farther out, we're going to reach, we don't want to associate it with any of these other points and being coincident and all of those things. So let's quickly trim out that centerpiece. So these arcs, and you can kind of do a center point, but a 3-point is going to give you a little better control over this. So we're going to make sure we don't have any association here. We're going to make it parallel, and then what we're going to do is we're going to change the radius. So if this were to be a circle, the radius here, what we can do is look at this, 5.05. This radius has, we can't recreate the same radius, but at a diameter of 20, even a radius of, if we set it to be something like a radius of 10, we're going to be a little bit mismatched. We want to make sure the distance between these 2 points horizontally is 0. So it's going to line this up. And what we can see is that curvature is maybe almost matching. So we could check this with what would the circle look like if we were at roughly, so that curve is slightly off center. This is the center point. What would that curve look like? You can estimate it as a circle with a 9.95 millimeter. This needs to be 20. This, let's see. I'm going to remove that circle and readjust this to be 20. So this will get you close enough, I guess, for the purposes of creating that curvature. You could say right at 10. a radius of 10. And then what that would mean is you could delete that curve. And then square this off, because what this drawing shows you is that these radii are related to each other. So this radius at half the distance being a radius of 5, which is half the radius of 10, is about right. The arc of curvature is about the same, but using this kind of 3-point arc is how you get there most quickly. So you could come in now and trim entities, take away the parts you don't need here. Pretty soon things will start screaming that all the reference dimensions are gone and nothing makes sense in the world anymore. So one of those we delete. Now we have our components. Now you have this little rectangular piece on the top. So this is a pretty quick thing to actually put together if you know what you're doing. But this gives you the basics for the shape. And so here, even if this is 1.5 millimeters tall or so, which, yeah, I think it's 1 point, I think the real one is actually a little closer to 1.5, which I think is what this says. Yeah, nope, those are totally other components. Come on now, I don't have time for this. There we go. Yeah, about 1.5 is actually more accurate for these. So about 1.5, and total width about 8.4. So I'm going to say about 8.5. And the distance here to here, 8.5 over 2, so that it's centered. And then we have our components. So now the only thing we're missing is that 2 millimeter shaft. So 2 millimeters. All right. Then we extrude this. So this overall length is the entirety of B. So for almost all these motors, it's the exact same 25 millimeters. So we're going to extrude this section, 25 millimeters. This top piece only extends by, let's see, I don't think either one gives it, only extends by about this much. This is about 6 millimeters or so. So we'll start with that. Do another extrusion. So the top, since this is a little bit of a trickier part and you guys can't just go in and lay hands on parts yet, I need to verify that we've got all the stuff that we need. Actually, it's going to be a little narrower. It's actually going to be closer to about 4.5. Yeah, that's about right. 4.5, roughly in that dimension. Overall length of that shaft is going to be from the back plane here. From that back plane, it's going to be about 34 millimeters, roughly. So extrude this central region, sketch 1, come on. This region, 34 millimeters. So about 34 millimeters. And then another about 12 millimeters or so out the back, give or take. The backside's typically just a hair shorter, so we'll see if 12 is pretty close. Reverse direction, it's actually going to be about 10. No, it's going to be, yeah, it's actually probably going to be about 10 because you also have the protrusion at the back there. So about 10. One more extrusion. of this base, other direction. And so this is another about 2.5 millimeters. So that's more representative of about what this motor is going to be in practical terms. There's some filleting and rounding and things that you'll be able to account for, but for the most part, this is your basic geometry for the motor. So I'm going to go ahead and save that into the group of files. Actually, so I'll go back and figure out where I've got the rest of those saved. So it might be 18. Yeah. Yeah, might be in here that I've got some more of them. Anyway, we'll do... Yeah, so I'll save this to where I've got a couple of the other parts, the Tamiya gearbox and some other things, which actually I thought was here. But maybe is not. So maybe it's a different one. Interesting. Okay, here we go. So, motor, make sure that's saved. Anyway, you're going to go through, you're going to get a couple of these parts made. So that's going to look a little more like this. So a little longer on the front end, a little shorter on the back end. You want to account for that small protrusion in the front as well. So that's factored into this length. It's a little longer on the front, a little shorter on the back. Fairly representative of the part that you see there. There's some filleting that you can do to the front. That'll get you a highly accurate part. You're also going to find wheel dimensions. So this is about right, roughly not quite an inch wide, but close. About 60 millimeter diameter. It's about right. The design is going to be a little bit different, but this will give you more or less approximate dimensions, including sort of rim face area. So back, what's called the back spacing on the reel. That's about right for a lot of the rim designs. So that should be pretty accurate for what you've got. And then create your battery box. These edges kind of curl up and around and match this curvature. So things to keep in mind. This will at least give you a pretty good idea what the dimensions look like. And then you're going to put together your chassis. So keep in mind here again, when you go to do chassis design, simple things that you can do to reduce the amount of time that it takes to print, and more importantly, reduce the likelihood of failure, is start with something like a rectangle, have another rectangle off the top, and then do some rounding of things. Then you're also going to want to do across the whole back edge. Maybe it's even on this outer edge, in order to give yourself some material to work with for heights on gearboxes as well as axles. You're going to want to do something like these bars all the way down. And for your motor mount, you might want to do some kind of offset block for your motor mount. And then you'll have a forward section, maybe like this, for your gearbox, a matching section back here for holding up gearbox. So you might have something of this general variety. Some of the tricks are going to be keeping in mind at the back, for instance, you might not have enough room. So you might have to make a cut here and make a cut here. And then trim these two pieces out. Trim that out. Maybe not trim that out. And what this will do is this will allow sort of one continuous part. So you do extrusion. This whole plate really only needs to be about 3 millimeters thick. We're going to reorient the total dimensions, kind of go back and edit this sketch, and the whole thing has to be less than like 170 millimeters anyway. So if we rescale this to be 160 millimeters in total, then when you lose your part, you go back and hit this button, zoom to fit. There we go. Exit the sketch. Now we have our base plate. Now what we can do is one more extrusion and create our walls for mounting axles and all the other components. So we come back in and we grab these regions, no thinning feature. So we grab this region, this region, this one, this one, this one, that one again, grab this one, and this one. Now, if we bring those up by, I seem to recall you need something like 15 millimeters or so. So get rid of this contour. So there we go. Something like 15 millimeters gives you something to work with. And then more importantly, what this does is this allows you a space to drop the front edge of the motor in and slot the back end down into place, but have this spacing be kind of a friction fit so that you don't have to use a lot of glue or anything like that. So the front nose of the motor right here, this front nose will drop into a circular hole designed to be kind of a snug fit. And then the back end will be designed to just barely touch either side of this. And it'll be a real snug fit. Plus, that'll mean this chassis prints quickly compared to a lot of other designs. And then you'll also have, you'll have to do some cutouts for where the gears are going to be on the bottom. That's fine. But if you position things low enough, you can also do things like taper these front edges. So you can do a chamfer. And you could do a chamfer on these front edges. So not that one, but this one. So you can do a pretty aggressive chamfer on the front as well as on the back to give you some clearance for body stuff and whatever else. There's a lot of options for how to do that. So you very quickly get to a sophisticated design. Chamfer there. Okay. You very quickly get to a sophisticated chassis design, and then you just set up your through holes for your gearing. Make sure your spacing is correct. Make sure you've got just enough clearance where you want the holes to be kind of almost like a real snug fit. You don't want them to be loose and flopping around because you don't want to have to come in with hot glue and make a royal mess. And what that does is leaves you a lot of room on the other side for your control board and for your battery box up here. So you might have to orient things a little bit carefully, but this should give you enough of a clearance starting point that with the dimensions from the battery box, with the dimensions of the battery box, the motor, some of the other things, you can start putting together a template for what your chassis will look like. And then for the body, what you want to do is get some key measurements and then design that over the top of your particular car. So you could very quickly do something, because a lot of students don't really understand, well, how would I do that? Well, you would start with something like the dimensions of this in the back end, and you would do another sketch, and let's say we do it on the surface of this. So we start a sketch and we say, all right, we want it to be something like, maybe we want it to look something like 30s Roadster or something extreme, and we want it to be look like something out of a cartoon and have wild flared fenders like you might see in some kind of crazy Bugs Bunny cartoon, or have it come up to crazy point because race car. So you bring this up, you bring this forward and up, and now you have an enclosed space, and you have maybe two portions of this. And because we're doing, 50s car styling, maybe to give you enough clearance, you need to do something. Let's see, let me go back to a spline or some kind of curved geometry. So maybe you want it to look something like a stylized version of a Roadster or something, right? What you can do is you can do something like an extrusion of this geometry, and you could cut the pieces of this that you don't need. So you might need maybe a little bit more space at the front edge or something like that in order to get the room that you need to clear gears or whatever. Maybe back here it's the same kind of problem. You need to bring it up. You need to bring it up. Maybe the same thing is true for this, and it needs to be a little taller to give you some more clearance for gears. That's fine. So then you can come in and trim the internal entities, do a simple extrusion. So you could do an extrusion of this all the way across up to surface, up to this surface. And what you could do is actually make it just a little bit wider then. And so change it back to a blind extrusion and give yourself some room. So give yourself a little bit of room internally. And what you can then do is do a shell with a couple millimeter thickness or something of that nature. But what you would need to do that is you would need to then do some sculpting on the sides, and we can show sort of how to do that in a reasonable way. So if you did this, now we come back in, we do some filleting along that curved edge. And it might only understand how to do this in like single digits. You may not be able to do something extreme. 5 millimeters probably compromises the geometry. 4 is too much. 3 is too much, but it understands 2. So 2 millimeter fillet on that side. Same thing. Fillet again. 2 millimeter on all of those edges. Something of that nature to round the edges of the body just slightly. Maybe up front here, you wanted a little bit more. You wanted it to be a little different profile. So we go back to the sketch 2. edit that and say, I really didn't like that. Maybe I wanted to drag this in and have it be more race car. Something like that. So keep in mind, if you do a zero clearance design like this, exit the sketch. If you do a zero clearance design, yeah, we undo and delete the fillets because they have no reference. They've lost their curvature reference. So now maybe it looks a little more like what you might expect, but you still want to go back in and do fillets or something like that. So you do this edge, this edge, this edge. And now maybe it doesn't have enough idea what to do with the geometry. So you clear selections and you pick maybe just this, or you click the front face or something like that. There's a couple different ways that you can do it. So there's a couple ways to approach it, but maybe it only has context for a 1 millimeter. And it might not have context enough for any filleting on this edge. But now you can start playing around with, okay, do we now want to have it set up where this is some kind of a wing design and we have a through hole or something like that, right? Do we want to have this have an exit so we can technically, if we want to do something really complicated, we add in our reference plane. We're going to pick 1, 2, 3 points. We're going to sketch something like that, and then do a, we're going to do a cut. So if we do an extrude cut out this way, it'll provide some mechanism for airflow. So if we now do an extrude cut, flip direction, because maybe we want the back open on our design, right? Maybe we now need to do some more extrude cutting, or we want to take this whole concept and turn it into a shell or something, right? There's lots and lots of different options for how you can do kind of a cool design based on a presentation like this, where you've got some kind of a curvature. You know, if you wanted to, you could do windows through the whole thing so that you could see inside. Like there's a lot of flexibility and options that you would have for this. So don't do lazy geometric shapes, like actually try and make something interesting out of this process. So this will give you some inspiration on how to do this. You'll want to make it as a second part using the same kind of dimensions, because when you create the part, you'll want to make sure that it is in fact a shell of the part. And so all this stuff, we really only want a shell thickness of about 2 millimeters, maybe 3, something like that. Something like 3 millimeters is very strong, very rigid in terms of 3D printed components. So show preview. Let's see if it can. It's going to throw me an error, you watch. Yeah, there's a maximum radius that's available. So 2 millimeters. Same thing that so it's you may not be able to use the shell type. You may not be able to use the entire thing. So what you might need to do in that case is, if you're stuck with something like that and you're trying to figure out how to do a shell and you're wasting a lot of time, go back to this sketch, or even just add another sketch. So exit that sketch, add another sketch on this surface, offset entities. So get rid of that. And now bring it to the inside, reverse, and make it something like 3 millimeters of the reverse. And then say, all right, based on this, we know we need some sort of cut through this way. We know that we're going to need actually a cut all the way down through here. So we actually are going to bring this whole thing down to the base and up. And we're going to cut this false base out because we don't need it. And we do an extrude cut with an offset of 3 millimeters to give us thickness, and leave about 3 millimeters offset to the other side of 3 millimeters and give us 71. So 65, it's pretty close. We need, 65 is actually just maybe one more than we need, because I didn't set an exact dimension on that, but that'll get us close enough. So now we have our empty shell underneath. Okay, and now we could put this down on top of our body with, if we needed to cut another access port or something for getting to our switch gear, or just mount our switch gear cleverly up under here on the underside of the wing, whatever we're doing there. There's a lot of options on how to make this a little easier on yourself. You might have to make a hole for cables or something. There's some playing around you'll have to do there. But you can do a few different design revisions, and then there you've got a simple, interesting looking body shape instead of just a rectangular block or something like that, and one that's going to fit fairly nicely with the way the wheels are going to work. So this should set on top of your chassis somehow. You might have to do a cutout for the exterior part of your chassis, right? For this to really sit down on it correctly, but you have some options on how to approach that. So hopefully this will give you what you guys need to do some much higher level examples of building the bodies on the chassis. So I'll try and follow up in the forum for any questions and try and make sure everybody's updated, but hopefully this helps you guys. In any event, have a great Thanksgiving, and we'll catch up with you next week.